Alright, here's our next one. I'd say pause this, take a look at it, see if you can't draw a picture and label the variables on your own before I start doing it. So take a couple minutes to do that. Alright, that should have been a couple minutes. So let me catch up to you guys. A pebble is dropped into a calm pond, alright, causing ripples in the form of concentric circles. So if you can imagine, you've got your pebble that's dropped, and then the circles, of course, expand out as you disturb the water. Or you could think of it kind of as a small circle that turns into a little bit bigger circle, that turns into a little bit bigger circle, and so on and so on. Um, and they each, of course, have a radius. So you have a small radius, and a bigger radius, and a bigger radius, then a bigger radius, small radius, bigger radius, bigger radius. And so the first variable that we want to think about is the radius. Alright, so I ask myself, does the radius change? Well, obviously it started small and got bigger, so it is changing. So we will have a dr dt. Alright. The next thing I see is area. So we do have area also, another variable. And as the circle gets bigger, the area definitely changes also. So there is a dA dt. I think that's all the variables we have in this one, the radius and the area. Do they tell us anything else? The radius r of the first ripple is expanding at a constant rate of 1 foot per second. Whenever you see the word rate, you should definitely think derivative. They are telling you a derivative of 1 foot per second. That is the radius expanding, so that is dr dt is 1 foot per second. When the radius is 4 feet, so I'm going to put 4 for the radius over here, but I'm going to do that tentatively. The radius is not always 4. That's what I'm sort of concerned about. That's when I want to do this problem. But the radius is not always 4. Just kind of remember that. Tuck that away in your brain. What is the rate of change of the area? So I'm going to take my area equation. Area equals pi r squared for a circle. Okay. And I want to find how fast the area is changing. So I'm going to take the derivative, and right now I cannot plug in 4 for the radius. Okay? We are interested in what happens when the radius is 4, but we can't plug it in right now because the radius is changing. And we need to take the derivative first. So I'm going to take the derivative of one side and the derivative of the other. So that equals, the 2 comes and multiplies down to the pi to get 2 pi r times. Now the variables don't match. The r and the t are different, so I have to add a dr dt. So when I look at that equation, I see that the change in the area is related to both how big the circle is and how fast the circle is getting bigger. It's related to both of those. That's why in the word problem they had to tell you the radius equals 4 and the change in the radius is 1 foot every second. Now that we have the derivative, now we can plug in some numbers. So oh, my computer is really angry. dA dt is equal to 2 pi when our radius is 4 times dr dt, which thankfully just 1. So that's going to give us 8 pi. And what are our units here? IC per second. This is area, so it's going to have to be square feet per second. And if you want to multiply out 8 pi, feel free to do so. I don't have a nice calculator handy to do that. But that is how fast our area is changing. Alright, hopefully this is getting a little bit clearer. We got 2 more.